Saxon Algebra 1, Lesson 14. Greetings, my students. We have a nice review lesson today that is important and useful, and I think you'll probably remember quite easily. It's called evaluation, but the best way to understand it is to look at an example. In the first one, John tells us, find the value of XMP if x equals 4, m equals 5, and p equals 2. Now, just to put a little bit of vocabulary onto this, when we have letters in an algebraic expression, like this one, we call them variables, or another word to describe them is unknowns, right? These letters, we can't do anything with those letters as is, right? We can't do a single thing with this. We can see we're multiplying three things together, but without additional information, this is meaningless. We can't do anything with it. However, if John assigns us values to the variables, that's what we say this is, we're assigning values to the variables, then we can take these values and plug them into this expression and then move the numbers ahead, however that means. In this case, we'll be multiplying, right? One important point that I think is obvious, but bears saying, is that if there were 3 different x's in what we're evaluating, this one there's just one x, every single place where there's an x, we put in a 4. Not just some of the x's, but all of the x's. Same for the m's and the p's. We'll see that in some of the other problems. We start out nice and easy with this one for John. The biggest tip I can give you in getting these problems right is use buckets or parentheses. For those of you who have less colorful interests in language, it's very easy to screw this up, especially when we have negative values. We don't have negative values in this one. It's just a straight multiplication, but sometimes we'll have subtraction and sometimes we'll have negative values, and it all turns into a giant mess. So please just use buckets. And what we do is we recreate the pattern of the letters by putting a bucket in for every letter. Then we pour the values in. X is 4, M is 5, P is 2. I multiply those two together to get 10, and my final answer is 40. And that's the correct answer, right? Let's try another one. Now, the first one, the instructions were find the value of. This time it says evaluate. That means the same thing. Evaluate means plug it in, plug the numbers into the letters and see what happens. That's the same thing as find the value of. Okay, this time we have some numeric coefficients or constants mixed in, right? That's what we can call these. Numeric coefficients. That's one way to describe these numbers. Or we can call them constants because their value is not going to change, right? These are variables because depending on what we want, we can change what we put in for each of those letters. These numbers are locked in, so we're not going to change those. But we have to know y equals 2 and z equals 10. So once again, we copy this, putting in buckets for every letter. So 4 bucket minus 5 is the way that works. And the 2 goes here, the 10 goes there. Let's see, we can multiply this in any order we want, and then we'll subtract 5, right? Order of operations matters in this. We multiply before we subtract. 4 times 2 is 8. Times 10, this means it's 80 minus 5. And so our final answer, our evaluation, is 75. These are all, it's all fun and games until John starts making crazy expressions for us. So far, he's being very kind, isn't he? They're cute and little. Let's try number 3. And just so you know, this lesson has 8 examples, but just this topic. So we're just going to practice increasingly difficult versions of this. This one is y minus z, where y equals -2 and z equals -6. It's no harder when we have negative values. We just have to be more careful. And this is a great example. We have a minus in the expression and we have minus in our values. So y minus z, and then we plug in -2 and -6 there. We can see it's just one step, so we don't have to worry that much about order of operations. 2 minuses go together to make a plus. We're on the ladder, right? We're at -2 and we go up 6. So let's see, the difference between 6 and 2 is 4. And the larger number is positive, so we know that our final answer is 4. Double check, make sure I'm right. Yes. Yay. Let's keep pushing on through these. 14(4). Okay, it's going to get a little crazy, right? So -a minus b minus a times b. So just thinking in terms of order of operations, we can see we'll need to do this first, and then we'll just go down the line with all those subtractions. A equals -3 and b equals -4. Okay, I've got all the information in front of me. I do recommend you copy these things down so that you have it all in front of you. Now I'm going to carefully create this. Lots of space so I don't feel crowded with my minus signs. -3 goes in every A spot. Now we're getting to a type of expression where we have more than one of each letter, right? So again, it's obvious, but it bears repeating that we put in the value for every single A, and we put in this value for every single B. B is -4, -4. Okay, so now let's simplify. These two go together to make a plus, so that's just plain 3. Those make a plus. We do the multiplication. Technically, we did it first. We're not changing the order of anything. And this is the way I like to do it. I count all 3 minus signs. I see there are 3 of them. That means my product is going to be negative, right? Some students might say, but wait a minute, shouldn't you cover this up? Multiply that, yes, we would get a +12, right? Then we take our finger off and it goes negative again. Oh, look, we get the same answer. So there are 2 ways to approach simplifying when there's a minus sign in front of a product. You can include it as part of the product, plus or minusing, or you can cover it up and then change at the end. Either way. Okay, 3 plus 4 is 7. 7 minus 12 is -5. Yay, that's the right answer. Okay, let's squeeze one more in here. 14(5). Evaluate minus x let me just double check this, make sure it's right. X equals 2, A equals -4, B equals -6. Okay, let me just double check this and make sure I've got all these crazy minus signs in the right place. Minus A oh no. My book's kind of in the shadows, so I'm being extra careful. Okay, perfect. All right, once again, we set up our buckets. And I exaggerate these parentheses. match to these parentheses. And then here are my two little ones for the A and the B. Okay, x is 2, and then A is -4, and B is -6. Okay, it's worth writing our order of operations down just so we have it in front of us, because this is an order of operations problem as well as an evaluation problem, right? Powers and roots, multiply and divide, add and subtract. Okay, so it doesn't hurt to have that handy. So work in parentheses first. These two together make a positive. Positive 4, so this is positive 4 minus 6, right? The difference is, they're opposite directions. The difference is 2. The larger number is negative, so this whole thing comes down to -2. Yeah? Then we bring this. I'm just taking the parentheses off. I don't need those anymore. -2 minus -2. Those two together make a plus. So it's -2 plus 2. That equals 0. That's the right answer. Oh, and that's strangely satisfying, isn't it? I like that one a lot. Okay, 3 more to go, and they're just getting more complicated. We have more letters, and we have a more complicated expression to evaluate. That's all that's changing these. Later, we will definitely make them harder, but this is hard enough for today. And this is one of those operations, this evaluation thing, that we're going to see lots of as we continue on through the years. So some things are kind of a dead end in that, we do them once and that's kind of the it, but this is not one of those things. Yeah? X minus y times quantity minus a plus x. Again, that's meaningless. It's just a bunch of unknowns / variables. It's only when we make this list that we turn this into an actual problem. A equals -4. Okay, great. So now we're ready to plug in. I'm going to rewrite this. And I'm going to do the big parentheses. Make sure I got it right. It's easy to make the little dumb mistakes in this, right? Super easy. X, I get a -2. Make sure you make your buckets big enough so that your minus signs don't scrunch up against them and you can lose track of them that way. Y is 3 and X is, oh wait, I did something. No, I did that right. This is A. A is -4. The X's are -2. Okay. All right, once again, order of operations. So we'll do this first. This becomes +4, and then this we can simplify as -2. We can see that summarizes down to just +2. I'm going to put the plus sign in there. Then we need to multiply that by 3, right? I'll copy all of this. It would be -2 minus 3 times this. We know that we don't subtract first. We multiply first, order of operations. So it's -2 minus 3 times 2 is 6. And so our final answer is -8. Yay! Got it right? That one was longer. This one's going to be even longer yet. Ready? Okay, as you're copying this, pay attention to what's happening and start thinking about order of operations as we go. I can see here we're multiplying 2 things together. So we're going to do work in parentheses, and then we will multiply and take the negative. So here I go. Big parentheses, I always make stronger. M plus X, that will be. And then the other parentheses minus a plus m times x, and there's the John's parentheses is how I think of them. All right, what are our values? I didn't write those down yet, did I? I'll put them over here this time. I like to always put them in the same place so that as I'm going and filling in the buckets, my brain knows exactly where to look. And later we will be doing problems where we always write our values like this over on the side. So if you like to just put them over here to begin with, that makes a lot of sense to me. I tend to write them over on that side like I've been doing. But now that this is longer, there's no room, so that's a drama. Okay, we've got two m's. M is 2. And let's see, it goes there, 2 at the front of this last multiplication. X is minus 3. A is 4. Now, John is usually pretty nice. He usually gives us these in order that they appear this way. So that's kind of a nice little extra, but that's something to pay attention to, is don't get scrambled up as you're moving from your list to plugging in. Okay, I'm going to simplify this side first. This comes down to 2 minus 3, right? There's my minus on the outside. 2 minus 3 is negative 1 times, okay, this is minus 4 minus 6. Does that make sense? I multiply these two together. That's a negative 6. I can drop off the plus sign. This I change to minus 4. That would be minus just a second, I'm double checking something. Minus 2. Oh, I see what I did wrong. No, that's right. Oh, I see what I did. A is a negative. I didn't write the negative. See, I had this negative that's in the formula, but I forgot to write the negative here. And I think it's because I made it too squishy and small and it just blended into the equal sign, which is not me making excuses, but it's me saying, look at how easy it is to lose track of your minus sign. So make your numbers clear and distinct. This then becomes positive 4 minus 6, and that becomes minus 2. This whole big thing summarizes to minus 2. Beautiful. Now I'm on track. Now all we have is multiplication. 1 times 2 is 2. 1, 2, 3 minus signs. 3 is an odd number. That means I do have a minus sign to my answer. Okay? Beautiful. I'm not encouraging you to be neat just because I'm uptight and fussy and I like everything to be pretty, although you might argue that that's true, right? That's not an untrue thing about me. I do think that things that are neat are more interesting and attractive, but being neat means you prevent mistakes, and that's the more powerful reason to do it. I have to tell you a side story. When I was in first grade, we were preparing our classroom for parent-teacher conferences, right? It was going to be in the evening. That's how they did it back in those days. It was kind of like a series of nights when parents would come in and talk to the teacher for like 15 minutes and find out how we're doing. It was first grade. So the teacher was trying to make the classroom look really cute. And she did the thing where she gave everybody one of those double-sized pieces of construction paper. And then on the bottom half of it, she gave us, some of that classic little kid writing paper that has the big extra lines. And then up here, we had pictures, or a single picture that had come from a magazine. We got to choose the picture, and the idea was that we chose a picture and then we wrote something about it. And we were supposed to write a page. And when it's that little kid, how the lines are like this, there's a top and a bottom, and then there's that, right? So this page fills up really fast. Well, the picture I chose was a little girl eating a bowl of cornflakes. And she was against a white background, and there was like a white floor, and then it just went seamlessly up into a white wall. So it was like not a room, but it was like a photo set. And what we saw is the little girl eating her bowl of cereal. Here's her cereal. But then, and she was here with her little dress on. Oh my gosh, I just made her completely disproportionate. All along here was a dribbly trail of spilled cornflakes and mess. Milk rather, right? Spilled milk and spilled cornflakes like all around her, right? That's the picture I chose. And I wrote, I mean, seriously, guys, I wrote like 6 or 8 pages of a lecture about how this little girl would enjoy her bowl of cornflakes so much more if she would have cleaned up her mess before she ate it. Because it's not fun to eat in a messy place. And so she really needed to, before she poured the milk, she should have swept up the cornflakes. And then if she spilled milk, she should have wiped that up first before she went ahead and ate her cornflakes. I kid you not. So I was 5 at the time. So I'm sorry. I do like things to be neat and pretty. But I also like them to be correct. And I don't like to have to rework problems. That's the main thing, you guys. Who wants to do a problem twice? It's bad enough doing all these problems once, but twice? No, you don't want to do that. Here's our last one, and then this lesson is over. Ready? Okay, that's our expression. A equals -2 and x equals 4. I've said it before, you already know this, but we have to make sure that every single a changes to -2 and every single x changes to 4. Excuse me, I'm yawning. Okay, let's make buckets. Here's my big John's parenthesis. Make sense? These are kind of wiggly. Okay, the a is -2. So I've got an A there and there. Whoops, I did that wrong, didn't I? -2. And then my X is 4. I have an X here and I have an X there. Okay, order of operations. I know I want to do the work in parentheses first, then I want to multiply, and then I'll add at the end. So let's do the work in parentheses first. These two go together to make a plus. 4 plus 2 is 6. Then I'm multiplying that 6 by 4 and -2. All of that is together, right? I'm ignoring that for now because that's separate, right? There's a plus sign, a boxcar, a connector between the train cars. All right, I multiply all 3 numbers. 2 times 4, I pointed to that and said 2, and I pointed to that and said 4. That's not right. 4 times 2 is 8. 8 times 6 is, say it out loud right now. That's right. And our signs are, let's see, we have 1, 2 negatives, so that means this is positive. And that's this whole expression, right? And then -2. So our final answer equals, I'll go this way to write it, 46, and that's right. You guys, you can do this anytime you want. Like before, I had that, right? Oh, I worked in the garden yesterday and my fingernails are still dirty. Sorry, don't notice. This was, I wrote this later, 48 -2, and I want to write equals 46. I feel like it's too crowded down there. So instead I went in this direction. You can do stuff like that all the time to make your work easy to read, but to avoid rewriting all the time. Rewriting all the time is a pain. It's a waste of time. That's why I don't want you to erase. Don't erase. Just draw a line through if you mess it up. But also, you want your work to be legible so that other people can see it. All right? Don't erase. Okay, the practice is straightforward on this. It's just evaluation problems, just like this one. And that is the end of lesson 14. Thank you. Goodbye.